All right, now we're doing 7Q number of divisions. This is by Fiskenslacht. Fiskenslacht. And 90% of the people like it. We're going to calculate how many times a number can be divided by a given number. For example, if the number is 6, the number 6 can be divided by 2 times. So 6 divided by 2 is 3. 3 divided by 2 is 1 remainder 1, right? And 100 can do it by 2 6 times. And here's the proof, right? So what we're going to do here, we're going to be using recursion. And if you don't know what recursion is, it's just the act of calling a function on itself to solve problems that contain smaller subproblems, right? And these are all smaller subproblems, right? So what we're going to do here for this recursive thing, first thing we're going to do is declare the variable for the result. But we're not going to bother doing it down in here. We're going to do it in the where the parameters are. We're going to make it a parameter. We're going to say result equals 0, right? And then we're going to do an if statement, and we're going to say if n is less than divisor, we're going to say return result, okay? Which, you know, until the very end, it's never going to be that case. And then after that, what we're going to do is we're going to say return, and then we're going to do the recursion. We're going to say divisions, and then we're going to say n over divisor, all right? And then we're going to say divisor, and then we're going to say result plus 1, okay? So it's just going to keep on going through each time until it gets to less than or equal to n, and it's just going to keep going and going and going until it gets down to this last one, and it's going to increase the result each time it goes through. Hopefully that makes sense to you. And let's see if this even works. Yeah, it does. All right. We're going to attempt it. We're going to say 33 milliseconds with that. Let's see if we can beat that. I'm pretty sure we can. Because there's a mathematical way to take care of this business. All right. Basically, if y'all remember, like if we do log of the bigger number divided by log of the smaller number, it'll give us how many times it's divided by. Like if it's the cube root or if it's the whatever root it is. All right. So like this one here, 8, the natural logarithm 8 divided by the natural logarithm of 2 equals 3, because 2 cubed is 8. So for this, we would say, and you can do it again for like let's say 16 and 4. How about that? And that's 2 right there, just like that. Okay, so knowing that, we can get rid of pretty much most of this stuff, all right? And what we got to do is we got to know about this Math.log. And Math.log function returns the natural logarithm base e of a number that is this blah, 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 right? And so for this, we're just going to say Math.log n divided by Math.log divisor, all right? Test it out. And we wanted to just cut off the rest of this stuff. So instead of that, we just say, what do we do? We wrap this whole thing up. And so we just say math.floor, which is right here. It's the function that returns the largest integer less than or equal to the given number, right? So it just pretty much cuts all this stuff off. So we'll say math.floor. And it should work. Let's see. All right, good. Attempt it. 27 milliseconds. All right, well, that's faster than 33. So this one wins today. All right, let's submit it. All right, my solutions, very much like this one. Just a few of us on this. Best practice in my opinion. And we'll see you next time.